power equations. P equals I squared R. Pretty standard concept in anybody that understands energy, right? Simple stuff, but some people don't. They just like to smear this stuff all around because they really don't understand it. But hey, it's how you say it, right? So P equals I squared R. That is one simple power factor. P equals I times E. Another power equation. Both of them related. Both of them can be walked through mathematically and show why one works and the other one works, and why they're related and how they're related. But one of the nuances in that energy equation is that letter R. Who knows about resistance? So resistance is a resistance to flow. A stream can have resistance. The rock bed in a stream creates a resistance to the water flow versus a smooth chute that lets the water flow out. You can play with those things and try them out and see, and then begin to go find out why and learn about fluid dynamics and flow and fluid motion and mass and energy transfers and vector. So get one little knock on a door can lead you into the rest of a career in these things. So yeah, energy equations, P equals I squared R. Now the nuance in there, that's an equation most everybody uses. Most every electrician is familiar with. Most everybody with electronics background is familiar with. But there's a nuance in there. P equals I squared R, and I mentioned R. R is resistance. Well, resistance, the formulas for resistance change with frequencies. Now, most people don't even look at that, don't account for it. They're using the right denominators in all their math, the common denominators. So this frequency thing isn't in there. P equals I squared R, no reference to F. But there's this thing called impedance, which can be thought of as resistance. It has the same properties. Only impedance is because high frequencies don't have the same properties on their energy transfer mechanisms as lower frequencies do. High frequencies begin to rely on very different properties, electronic properties, because of the energies involved and the excitation energies involved. These high frequencies don't travel in wire, they travel on the surface of wires. So you're not worried about resistance anymore, you're worried about something called inductive capacitance, and it's the closeness of the wire, whatever the wire is made of, copper and some other materials, because ultra-high purity copper is expensive. It's not what you get in your normal house wiring. So, yeah, it's a huge friggin' world out there. Frequencies are a part of this world. If you don't know that subtle transformation of the R value in P equals I squared R, and when you're required to worry about impedance versus resistance, R, capital R. Lots of equations to derive what R is in a complicated circuit. None of them derive true-false values. They drive an empirical value that you have to make a decision on, a relative value, relative to what you know and understand and can speak to. So there's resistance and a speak around impedance, X sub L, X sub C. A whole another series of videos and introduction to a career if you're interested in this stuff. But hey, throw a negative electron in here, because that's what we're talking about in the field of nuclear decay particles, you pedantic. Good morning. Good coffee. Peace is out.